Hi folks, today we're going to do section 5.1, but we're going to start here with a launch just to kind of get you into the mindset for all of chapter 5 and for chapter 6. So the first half of this semester we've talked a lot about slope and every way that you could find slope, which is derivative, and then all the different rules that we have to find derivatives, including quotient rule and product rule and chain rule. And so now we're going to shift gears a little bit. Instead of talking about slope, we're actually going to be talking about area, okay? So we're going to talk about area, we're going to talk about how area relates to slope, and we're going to start here with some refreshers on geometry. Okay, so we've got this diagram here. Weird looking function, but very nice in terms of geometric shapes, okay? So you'll notice that over here we've kind of got this triangle situation, and maybe we know the area formula for a triangle is 1/2 base times height. And over here we've got this trapezoid, okay? And that the area formula for a trapezoid is 1/2 base 1 plus base 2 times height. Yes, you can cut it into a rectangle and two triangles, but the area formula for a trapezoid is actually handy to know. We also have this semicircle here, okay? And so the area for a circle is pi r squared, but we're going to cut it in half because we only have a half a circle here. And then this last shape kind of looks like the first shape, triangle, but only this part of the triangle is visible, and so when there's no end point, we sort of drop that perpendicular so that we can create a shape. And so this triangle area is also 1/2 base times height. Okay. So now let's ask ourselves a few questions about area. So part A says find the area between the curve and the x-axis from 0 to 6. And so what they're asking us for is to find this area right here or use this area formula. So let's go ahead and plug in the numbers. Area equals 1/2. Base 1 is 6 plus base 2 is 3, and then the height of this trapezoid is 2, and so that's going to give me an area of 9 for that. All right, let's move on to part B. Part B says, find the area between the curve and the x-axis from 6 to 8. So we're looking at this area here. Now, this area is, we can use the area formula for a triangle, but it's also underneath the x-axis. And so, because we're reading this way, and it's underneath the x-axis, we're going to say that this area is actually negative. And then we're going to use our area formula, and we're going to put a negative sign in the front when we're done. Area equals 1/2. Base is 2 plus, not plus, times 2 times the height, which is 3, and that will give us an area of 3. We're going to make sure that we make it negative because, like we said, we're reading from left to right and it's below the x-axis. Okay, let's take a look at part C. So part C says find the area between the curve and the x-axis from 0 all the way to 8. So in this case, they actually want us to take our area of the trapezoid and they want us to add it to the area of the triangle. And we're going to keep the signs where they are. So we'll get 9 plus a negative 3, which will give us an area of 6. Okay, part D. Find the area between the curve and the x-axis from 0 to 7. So this time let's get some color up here. I am starting here at 0, and I'm counting to 7. So only half of my blue triangle, but all of my green trapezoid. So that means that I have the area of the trapezoid plus 1/2 the area of the triangle. And that's going to give us 9 plus 1/2 times negative 3, or that's going to give us, let's see, 9 minus 3 over 2 is going to give us 7.5. So you can take a whole shape, you can take part of a shape, the area can be positive, the area can be negative. Those are all things that we want to consider, okay? Okay, let's take a look at the next 4 questions. So part E says find the area between the curve and the x-axis from -7 to -4. Now -7 to -4 is that triangle down there. And I'm asking you to go from -7 to -4. And so as I read from left to right, kind of like this triangle here, I'm underneath the curve, so this area is also going to be negative. And I'm going to plug in the numbers. So area of the triangle equals 1/2. The base is 3, the height is 3, and so I get an area of -9 over 2. Okay, part F. Find the area between the curve and the x-axis from -4 to 0. So that is this part right here, -4 to 0. And as I go from left to right, it's above the axis, so my area is going to be positive. And I'm going to use the area formula for my half circle, so my area will be 1/2 pi times my diameter is 4, but my radius is only 2, so 2 squared. So that'll give me 4 pi over 2, or just 2 pi. Okay. So far, so good, I hope. Part G. Find the area between the curve and the x-axis from -4 to -7. So what I'm asking you to do this time is take a different perspective. That instead of going from left to right, we're actually going from right to left. Now, when we go in the opposite direction, it means all of our signs are the opposite of what we think they are. So if I'm reading this backwards, this is saying I'm reading backwards and it's negative. That's actually going to make this a positive area this time. And so I can take my answer from part E and just make it positive. So this area will be 9 over 2. Okay? So like many things in life, it really depends on your perspective. If you're going left to right, everything is as it seems. But if you're going right to left, then everything is the opposite of what you think. All right, one last part. Part H. Find the area between the curve and the x-axis from 0 to -4. So same thing this time, I'm asking you for that same semicircle area, but I'm going backwards. And so this area is actually negative because I'm reading it backwards, and so the opposite of positive is negative, which means I can take my answer from part F and just make it negative 2 pi, and there I go. Okay. So over this next half of the semester, we're going to look at a lot of different ways to find area, and we're going to talk about some new symbols as well. And so I just want to introduce those new symbols on this next page, and then we'll call it here for the first part of the 5.1 video series. Okay, so this time we're going to focus more on the notation as we already have the answers from above. So part A says find the area between the curve and the x-axis from 0 to 6. So the way that I could write that is I could say the integral from 0 to 6, and let's call this f of x and x, of f of x dx. And I knew that my answer was 9. So I can say that that integral equals 9. I can do the same thing for part B. I can say the integral, but I'm going to start at 6 this time and go to 8 of f of x equals, what did we have? Negative 3. Okay? And we can say that the area between the curve and the x-axis, so area from 0 to 8 of f of x dx was 6, and the integral from 0 to 7 of f of x dx equals 7.5. So that integral symbol is what we use to say, hey, I want you to find that area. And the numbers, this little number on the bottom, so let's go ahead and highlight that. These numbers on the bottom, they tell you where to start counting your area. And these numbers on the top, they tell you when to stop counting your area. So the bottom is where you start, and the top is where you stop. So area, start, stop of your function, and you'll need a dx at the end. Okay? So let's just finish up these last 4. We're not recalculating anything. We're just going to use our answers from before, but we're going to set it up with our notation. So we had the integral from negative 7 to negative 4 of f of x dx equals, and we said that that area was negative 9/2. That means that for g, we can say the integral from negative 4 to negative 7 of f of x dx equals 9/2. And you'll notice that all we did in E and F was switch the top and bottom, and what happened is then we just had to switch the sign of our answer, okay? And that's actually a pattern that we'll learn a little later on. So top here, but it's a different top over here. And negative 7 is the bottom here, but negative 4 is the bottom here. And so that really matters. The direction that you go in really matters. All right, last 2 here. Find the area between the curve and the x-axis from negative 4 to 0 of f of x dx. And we said that that was going to be negative 2 pi. Oh, shoot. Sorry, 2 pi, positive 2 pi. And last but not least, the integral from 0 to negative 4 of f of x dx equals negative 2 pi. And there we're going to stop it for this first part, and I'll see you back here for part 2.